Okay, well, I have plenty more I could say about this, but I think in the interests of lunch, I will stop there.
Thanks. Yeah.
Quick question. Do you know a good place that has paper placemats?
I don't know off the top of my head which places have paper placemats. You can always actually bring paper is also an option.
Yeah, it tends to work.
You're welcome.
Okay, I need another volunteer to lead a discussion about this session. We can't go to lunch until we have this debriefing discussion. Whose name here?
You don't want to pick? I can pick. Okay, Jill, you want to do it?
Okay, thanks, Jill.
Yeah.
Do you want me to go just like with the 3 questions that we did?
Whatever you would like. You're in charge.
For that. Alright, so write down what you learned about problem solving, what you learned about teaching, and how was this the same or different than the last 2 days.
We learned how to teach math.
What you learned about problem solving.
Okay.
One difference that I see, and I'm not a middle school teacher, but I see this as something that you could take immediately and do it with children without trying to think of how it connects, because they clearly just have to multiply and divide.
So
and
this one you think is the most
I think this one,
applicable to the classroom immediately.
yeah, I think this one's the most immediately applicable. And I don't know if y'all think that too, but
I think this could be about problem solving or about teaching problem solving, but the prior knowledge can inhibit thinking of things in new ways. Like in this case, I have so fixed into my head an algorithm for multiplication that it's hard to think of it and how to describe it in terms of these dots, really. I'm immediately just trying to translate my algorithm into the dots instead of actually thinking of it in terms of dots. So, I don't know how to word that. Prior knowledge inhibits creativity or inhibits...
Actually, my comment is kind of related, maybe to maybe us to express that. Generally, well, no pun intended, but oftentimes when you're introducing something, you'll start with the familiar and then gradually leave it. And in this case, he started with binary, so it was unfamiliar, and then brought it back to base 10 so that we could see, oh yeah, well, this is essentially what we're used to doing, and then left for more, distant lands. And so I think it's not always the case that you should start with the most familiar. And in my opinion, I think that worked really well. And so I think what occurred to me is that it's not always the case that you should start with the most familiar example.
Start with unfamiliar, and then work your way into the familiar.
Well, no, just the opposite. That sometimes it's better to start with something a little less familiar, and then it comes back to something familiar, and then, so if this is familiar and this is unfamiliar, he started here, bounced there, and then shifted over here. And I say this because I taught something similar, and I started with the most familiar, and it didn't go very well. So now if I do this again, I think I'm going to start with base 2, binary, or whatever.
I just am thinking about the model in general, and as I was going through it the first time, I could connect some things that we were doing to traditional algorithms, right, for borrowing, but it allowed more flexibility, and we weren't saying you have to start with this number and then move to the some of the order and direction that are associated with those traditional algorithms. We could move a little bit with yeah. So I thought that was interesting. I don't know how it relates to any of
Write that.
flexibility with the algorithms.
Under this one?
Yeah. think that's kind of a similarity though to what we've been doing. The more open the problem with the less stipulations and requirements on it, then that allows that thing that you're talking about. We've experienced that, I think, in every system.
Yeah, the openness.
There aren't a lot of parameters, so you can kind of do it.
Multiple ways to solve it.
We do in my pre-service course, which is, again, it's basically the same kind of thing we're doing here, is working in base 5. A nice concrete model in base 5 is pennies, nickels, and quarters as a way of representing what's going on. So trading, basically, trading, if you had 6 nickels, that would be a quarter and a nickel, and, kind of working back and forth as a concrete representation of the same idea in base 5.
Thank you, Jill. Thank you. Anyway, thank you so much for your work and your time this morning, and have a good lunch. See you at 2:30.